This is our experiment measuring shear force in a beam. Going to place a load on the beam just to the left of this midpoint cut, and we're going to measure the shear force that we generate as we add load to it. So we'll start by putting 100-gram force at the 260 millimeter from the hinge for the point of support. So we will again, we're using the mass 100, 200, 300, 400, 500 grams. And our corresponding load, 0.98 newtons for 100 grams, 1.96 for 200. And our force readout in this case is 0.6 newtons. We increase the force, go to a 200-gram load, or 1.96 newton load. My force reading is 1.1 newtons. We should go up fairly linearly. So when we add a third 100, it gives us to a 300-gram load, 1.7 newtons. So we're moving fairly linearly within the level of precision of the instrument. So when we go to 400 grams, our reading is 2.2, which is exactly twice what we got for 200 grams. So we're moving fairly linearly. And we add another 100 grams and go to a 500-gram load, giving me 2.8 newtons. This is my shear force computed at the cut. The calculation for that is in the lab instructions. Okay, having done that, we want to look at some alternative arrangements of force and see how it affects us. Start with the force on the outside of the support. So this portion of the beam goes into cantilever. So I have a negative load of 1.2 newtons. My force reading is negative 1.2 newtons. And again, to do our computations, we've got to go in and establish this load, look at the equal moments about one of the points, and determine what the load at each of these is, the reaction that's holding this beam up. That's our first one. Second one, want to look at having two loads, 200 gram and 400 gram. Make sure we get them all in the correct order. It's my 220 here. I'm sorry, the 200 gram and the 400 gram. At those distances, and my shear value is 3.1 newtons. The third one move around a bit. I need 400 grams. I mean 500 grams at 240 out, and 400 grams at 400 millimeters from the origin, setting my origin here. And my shear at that point is only 2.2 newtons. And you'll need to do the shear force diagram to establish why that is as it is.